Hello there, welcome to a quick demonstration on how you can resolve a least squares regression using Excel. Now in this particular demonstration, I'll be using the scattergraph as the basis for resolving the least squares regression. Right, but again, as usual, it's always important to understand the definition of the concept. Right, what is the working definition? The least squares regression is a method that is actually used in statistics for the purpose of finding the best fitting line through a set of data points. Right, so again, the goal really is to minimize the sum of the square differences between the observed values and the values that are actually predicted by the line. Now that sounds a little bit complicated, but an alternative way of actually understanding is that you have to imagine that you have a bunch of data points on a graph, and the least squares regression is that act of actually drawing a line through those points in a way that the total error or the vertical distance from each point to the line is as small as possible. Now, once again, it may appear a little bit complicated here, but you're basically saying, given the data spread on your graph, where would your best line be, right? That would, to some extent, will be close enough, or in other words, for lack of a better term, want to find a line that hugs your data points closely. Now, using the scattergraph, we'll also be able to derive the equation, which is the linear equation y is equal to mx plus b, right? So the conventional linear equation. And once we have this equation with some values on it, we'll be able to predict the market value if we're given a square footage. And in square footage, we can actually substitute it into that equation, and we'll be able to calculate a market value. And then that way, we'll actually have derived a model that can really work for us, and also at the same time minimizing some errors. Okay, so now that we've gotten the working definition out of the way, we can remove the definition so that we can have some space here to plot our graph. Now the data set is right here, and so what we need to do is to select the data range that we need to use. So then we can go ahead into insert, and under insert we want to go to charts group, and we want the scatter graph that will show us some data points. All right, so we can see here already that we do have some data points, and then we can clean up a little bit. Here we can see that the square footage does not start until about maybe 1,400. So we can go ahead and change the minimum to 1,400. And also the market value does not start until about 55,000, thereabout, no, maybe 65,000. So again, we want to change the minimum to 65,000 so that our graph looks a little bit cleaner in that regard. Okay, so we can expand it so that we can actually see the different data points. So once again, once we've done this, you can see if you go back to our working definition, right, is that we've got a bunch of points on a graph, right? We can see them there, and the least regression, least squares regression is like drawing a line through those data points. Where can we draw the line? Right there. Okay, so already we can see that there's actually some kind of pattern that's actually emerging from these data points from left to right. So, but again, we couldn't guess where we can actually draw the line. Now, Excel can actually help us do that, right? So what we do is we go into that plus sign, and under that plus sign, we can see there's a trend line. If you put a check mark on it, it draws the line for us. Right, but then again, can we bring more meaning to this particular line? Yes. If you hover your pointer on trend line, you'll see there's a list arrow to the right. Click on it, and there's more options. And under that, you'll be able to see there's a display equation. So we can actually derive the equation right there. And we can place it wherever we want it to be. And then of course we click back on the line as well, and if we wanted to see the R square, which is the coefficient of determination, which is basically telling us how much of the variation, how much of the market value is actually explained by the square footage. It's currently at 53%. Right, so once we've done this, we are actually able to use that linear equation to predict. Right, for in this particular case, we know that the square footage is our predictor, which is our independent variable, and the market value is the predicted, which is the dependent variable. So in this case, it means that we can predict any market value if we know what square footage we are actually using. Right, so let's say, for example, you go down this square footage, and there's no square footage that is exactly the same as the one that you're actually looking at, that you're actually aware of. So you can say, well, okay, I can plug it in and I should be fine. So I can plug it in where there's that X. So in this case, let's say we are looking for a house with a square footage of 1,750, right? I've already checked that it's not on this list here. So all we can do is we can say Y is equal to, right? And we do know that it's 35.036. That is actually our slope, multiplied by the square footage, 1,750, closing parenthesis, plus our intercept, which is 32,673. Okay, so basically that's basically how we are actually going to use the linear equation. So I can copy this on a separate spot here so that I can insert an equal sign to the left of it, and Excel will recognize this as a formula. And it does tell me that a house based on this a least squares regression, a house with square footage of 1,750 will actually have a market value of 93,986. Right. So again, we can, we can format the value that way. So you can see really the power of using a scatter graph for the purpose of resolving least squares regression. And we are actually able to derive the linear equation. And of course, we're also able to also understand the fitness of this particular line. It's at about 53%. So it explains, that's quite significant, right? It does explain about 53% of the market value. So at least if it's all subject to how the data is actually spread. We do have some outliers there, a couple of them, and as we go further up here, we can find that most of the values are actually above the line, and we don't have as much below that particular line. But most of it's actually dependent more on what happens at the beginning right there. So again, you would expect that the line will be the data points will be much closer to the line if the sample size was larger, and also also if they were I would say, let's say the R square was actually going to be larger than 53%. Let's say, for example, the R square was explaining about 70%. You'd expect the data points to also be reflecting that as well. So here you are. Excel can really simplify some of the things that not long ago were not possible at all. You'd need to be using some advanced statistical analysis tools in order for you to be able to do that. But at least Excel is now bringing everything into the mainstream so that we can have more practice. And therefore, we become much more comfortable with some of these concepts, which not long ago would not have been achievable at all. Otherwise, that's all I have for you. Thank you so much for watching. And again, like the video, like it, share it, and be sure to subscribe. I really, really appreciate it. Thank you so much, and bye for now.